Before we discuss the question, I want to do a short revision for significant figures. So there are some rules for significant figures. First one, all non-zero digits in the number are significant figures. So let's say example 1, 568. So 5, 6, 8 here are non-zero digits. So all of them are significant. So we have 1, 2, 3, 3 significant figures. Okay, for significant figures, we have to count from left to right. Always count from left to right. So we start from 5. 1, 2, 3. 3 significant figures. Example 2. 36.97. Even though there's a decimal, we also count from left to right. And all the numbers here are non-zero digits. So all of them are counted. So 1, 2, 3, 4. 4 significant figures. Rules number 2. All zeros between non-zero digits are significant. Example, 7,001. So zeros here are in between 7 and 1. These two zeros are counted. They are significant. So we have 1, 2, 3, 4. Altogether, 4 significant figures. Even though there's a decimal, also implies. For example, 0 in between 3 and 4. So 3.04. 1, 2, 3. 3 significant figures. Number 3. 0 between 2 and 5. Also counted. So 1, 2, 3, 4, 5. 5 significant figures. Rules number 3. All zeros that lie on the right of a non-zero digit in a decimal are significant. Okay, this implies for decimal. Example 1, 0.70. So 0 here at the back of the decimal, this is significant. The 0 in front of the decimal or in front is not counted. So for example 1, we only have 1, 2, 2 significant figures. The first 0 is not counted. Okay, the 0 in front of a non-zero digit is not significant. Okay, number 2, 4.500. So 0 here is behind the decimal. So these two zeros are all counted. So we have 1, 2, 3, 4, 4 significant figures. Number 3, 3.00. So this one is 1, 2, 3, 3 significant figures. D, zeros that lie on the left of a non-zero digit in the decimal are not significant. Okay, just like I said just now. The 0 in front is not counted. So for example 1, 0.05. Okay, these two zeros are not counted, so only 5. So only 1 significant figures. Example 2, the 0 in front are not counted, only 4 and 0 here, so 2 significant figures. Number 3, 0.0. These two zeros are not counted, so 1, 2, 3, 4, 4 significant figures. Last rule, zeros at the end of a whole number are to be considered as non-significant unless stated otherwise. Okay, for example, 40. This is a whole number. Okay, the 0 here are to be considered as non-significant. So for this one, only 1 significant figures because this 0 can be considered as non-significant. Or if the question says this whole number has 2 significant figures, also correct. Number 2, 3670. So altogether 1, 2, 3, 3 significant figures. But if the question says the 0 here is counted, then 4 significant figures, also correct. Number 3, 704200. So only 1, 2, 3, 4, 4 significant figures. Unless the question says, okay, this is 6 significant figure. Question 1. Round off 0.9058 correct to 3 significant figures. So for the original one, there are 1, 2, 3, 4, 4 significant figures for this number. Okay, because 0 in front is not counted, so 1, 2, 3, 4. Then how to correct it to 3 significant figures? So we always start from left to right when we count the significant figures. So the first 0 is not counted, so 1, 2, 3. This is the third significant figure, so we underline it. Then we circle the number beside it. So 8. 8 we have to round up. So we plus 1 to 5. So you have 0.906. So the answer is dot. Number 2, find the value of 4 minus 0.215 divided by 50 and round off your answer to 2 significant figures. So first you use your calculator to calculate this. Okay, we calculate the bracket first. 4 minus 0.215. Then you will have 3.785. After that, we divide it by 50. So the answer will be 0.0757. Okay, you can use your calculator to find the answer. So for this one, this is okay, 0 in front is not counted, so 1, 2, 3, 3 significant figures. But the question wants 2 significant figures. So this is the first significant figure, 1, 2. We underline 5 and then circle the number beside it. 7, we have to round up. So we plus 1 to 5. So the answer is 0.076 D. Number 3. Which number is rounded off correctly to 3 significant figures? Okay, we try one by one. So for A, numbers here, 1, 2, 3, 4, 4 significant figures. Round off to 3 significant figures. 1, 2, 3. Then we circle the number beside it. 6 have to round up. So you have 0.0275. Okay, A is correct. So we try the rest also. For B, 0.02756. The 0 in front is not counted, so we start from 2. 1, 2, 3. Underline, circle. 6 have to round up. So the answer should be 0.0276, not 5. C, 1, 2, 3. Okay, we underline, then circle the number beside it. 4 does not need to round up. So the answer is 52100. 100. Okay, D, 52270. So 1, 2, 3. Then circle the number beside it. 7 have to round up. So the answer is 52300. Number 4. Which of the following becomes 0.06 when it is rounded off correct to 1 significant figures? Okay, so let's try it one by one. A. So the 0 in front is not counted. So 1. Okay, this is 1, first significant figure. Okay, circle the number beside it. 8 have to be round up. So 0.06, correct. Try the rest also. 0.051. Okay, 0 in front is not counted. So 5 underline. 1 does not need to round up. So only 0.05. C. So 0 in front is not counted. So 6 is the first significant figure. Circle the number beside it. 1 does not need to round up, so the answer is 0.006. D, 0 in front is not counted, so underline 5, circle 1. 1 does not need to round up, so the answer is 0.005. Okay, the answer is A. Number 5, calculate the value of 65.98 minus 5.72 divided by 0.5 and round off the answer correct to 2 significant figures. Okay, so you have to use calculator to calculate the value. But remember to do the division first. Okay, 5.72 divided by 0.5 first. Later, 65.98 minus the number. Okay, for this one, if you use your calculator to find, then you will have 54.54. Okay, you get the answer 54.54. Correct to 2 significant figures. So first, second, then we circle the number beside it. 5 had to be round up. So the answer is 55. D. Number 6. Diagram shows a right angle triangle. Find the value of x and give the answer correct to 2 significant figures. Okay, to find x, we are going to use Pythagoras theorem. So 6.x squared equals to 4.7 squared plus x squared. This is Pythagoras theorem. Therefore, to find x equals to square root of 6.x squared minus 4.7 squared. Then you use your calculator to find. The answer will be 4.914. Then we have to correct it to 2 significant figures. Start from left, 1, 2. Okay, we underline 9 and then circle the number beside it. 1 does not need to round up. So the answer will be 4.9. This is in 2 significant figures. The answer is boy. Okay, start from number 7. This is in standard form. So what is the meaning of standard form? The formula of standard form is like this. A multiplies with 10 power n. And A must be in the range of greater than 1 but less than 10. So A can be any numbers. Let's say 1.1 or 2 or 9.9. But it cannot less than 1. Okay, it cannot be 0.9. Cannot. And also it cannot be bigger than 10. So let's say it cannot be 10, cannot. And also like 12.5 also cannot. Okay, so this is the standard form. And here it can be positive integer or negative integer. It can be positive number or negative number. So let's say n here it can be 10 or it can be negative 25. Okay, and so for number 7, 300.6 times 10 to the power of 12 is written as, okay, so this is in standard form because the number here is in between 1 to 10. In the standard form, set the value of q. Okay, so how to rewrite this into standard form? So we have to move this decimal to the front. So 1 time, 2 times. So we move the decimal 2 times to the left. Therefore, we have to plus 2 to the power. Then you will have 3.006 times 10 to the power of 12 plus 2, 14. So the answer is q equals to 14. Number 8. It is given that 0.000000069 equals to k times 10 to the power of n, where k times 10 to the power of n is a number in standard form. Okay, so we have to write this number in standard form. We have to move the decimal to the back. 1, 2, 3, 4, 5, 6, 7, 8 until this one. So you will have 6.9 multiply with 10. Okay, if you move the decimal to the back, then it will become negative. So how many times that we have moved? 8. So negative 8. So k equals to 6.9, n equals to negative 8. So the answer is A. Number 9, 4.7 times 10 to the power of 5 plus 850,000. So this one, we have several methods. The easiest one is, okay, we change this to normal number. So power 5, that means we move the decimal to the back 5 times. So 1, 2, 3, 4, 5. So this number should be 470,000 plus 850,000. Then you press in this value into your calculator. You will have 132,000. Then we change this back to standard form. Okay, the decimal is at the back here. 1, 2, 3, 4, 5, 6. The answer will be 1.32 times 10 to the power of 6. So the answer is boy. Number 10, 5.27 times 10 to the power of negative 8 minus 1.30 times 10 to the power of negative 9. Okay, so if you can press your calculator in this form, then you can just press in straight away. But if you can't press the power, then you have to change it to normal number. So let's say this one, this is negative 8. So we have to move the decimal in front 8 times. 1, 2, 3, 4, 5, 6, 7, 8. Then you will have 0.00527 minus negative 9. So we move the decimal to the front 9 times. So you have minus 0.130. Then you do this in your calculator, you will have 0.00. Okay, change it to standard form. So 1, 2, 3, 4, 5, 6, 7, 8. So the answer is 5.14 times 10 to the power of negative 8. 11, 1.44 times 10 to the power of negative 7 over 0.0009. Okay, for this one, you can also key into your calculator straight away. Then you will have the answer. 1.6 times 10 to the power of negative 4, C. Number 12. Okay, for this one, 3 times 10 to the power of 3, then power 3 again. Okay, so 3 belongs to this number and also this. So for this one, you will have 0.081 divided by 3 power 3 is 27 times 10 power 3 times 3 again. So 3 times 3 you will have 9. Okay, keying this value into the calculator, you will have A. Question 13, you only need to key in this value into your calculator. Then you will have the answer boy. Okay, 14. Convert 72 meters square to cm square and express the answer in standard form. So 72 meters square. This is equals to 72 meter times 1 meter. Because 72 times 1 is 72. M times M will be M square. Okay, after that, meter to centimeter. So multiply by 100. So 72 multiplied by 100. So 7,200. 1 meter, change it to centimeter. So 100 centimeter. Okay, this is in centimeter. So 7,200 multiplied with 100. You will have 720,000. Centimeter times centimeter, centimeter square. Change it to standard form, so we move the decimal 1, 2, 3, 4, 5, 5 times to the front. 7.2 times 10 to the power of 5. Answer is A. Number 15. The length of a side of a square piece of land is 3 km. Calculate the area in meters square of the length and express the answer in standard form. So there is a square length. Each side is 3 km. Okay, the question asks us to change it to meter square. So we change it to meter first. So 3 km equals to 3000 m. Since this is a square, all sides are the same. So here also 3000 m. To find the area, 3000 times 3000. So you will have 9,000,000. M times m square. Change it to standard form. 1, 2, 3, 4, 5, 6. So 9.0 times 10 to the power of 6 meter square. The answer is C. Perimeter of a rectangle is 5.52 times 10 to the power of 3 meter. Given its width is 1.6 times 10 to the power of 2 meter. Okay, you can change it to normal number first. So 10 power of 3, we move the decimal to the back 3 times 1 to 3. So this should be 5,520. Okay, the width 10 power of 2, so we move the decimal to the back 2 times. So this is 160 meter. Okay, so for a rectangle, width is 160. That means this side also 160. So let's say the length is A. To find the length, we just use 5,500 to. Okay, to find the value of A, we just use 5,520 minus 160 and then divided by 2. Okay, so A equals to 5520 minus, you have 260. So 2 times 160. Then we have to divide it by 2 because these two sides are equal. Then you use your calculator to find, you will have 2,600. Change it to standard form. 1, 2, 3. 3 move to the front. So the answer will be 2.6 times 10 to the power of 3. Boy. Number 17. One Zaiton has 280 kg of flour. She uses 60% of the flour to bake cakes. The remaining flour is divided into 4 bags. Find the mass in gram of flour in each bag. Okay, so since the question asks us to find the mass in gram, we can convert this kilogram to gram first. Kilogram to gram, so we multiply by 1000. So you will have 280,000. And Point Zaiton uses 60% to bake the cakes. Therefore, the remaining flour will be 40%. So what is the mass of this 40%? 280,000 multiplied with 40 over 100. Okay, use your calculator. Then you will get 112 0 0 0. This remaining flour is divided into 4 bags. So 112,000 be divided into 4, divided by 4. Then you have the answer 280 gram. Change it to standard form 1, 2, 3. So 2.8 times 10 to the power of 3. The answer is A. 18. It is given that 15 solid metal cones each with a radius of 35 cm and a height of 60 cm are melted to make 70 identical solid spheres. Find the volume of each sphere. Okay, so we have a cone. With a radius of 35 cm. So the radius here is 35 cm. And the height is 60 cm. Okay, this is the height. 60 cm. So what is the volume of one cone? The formula for cone is 1 over 3 pi r square h. So we are going to use this formula to find the volume of one cone. Then you will have 1 over 3 pi given 22 over 7. R is radius, so 35 square. H is the height, 60. Okay, use the calculator. You'll get the answer 77000. This is for one cone, but you are given 15 cones, so you have to multiply by 15. Multiply by 15. 1155000. As much of volume of metal cone is melted, then it has to melt to 70 identical solid spheres. So to find the volume of one sphere, you just need to divide it by 70. Then the answer will be 16500. Change it to standard form 1, 2, 3, 4. So 1.65 times 10 to the power of 4. Boy. Number 19. The total population of a city is 8.25 million. It is given that the number of people who are 40 years of age and below is 64% of the total population. Calculate the number of people who are above 40 years of age. 1 million equals to 10 to the power of 6. So that means the total population here will be 8.25 times 10 to the power of 6. Million is 10 to the power of 6. Okay, so 64% is below 40 years old. So 64% is below 40 years old. So how many percent are above 40 years old? 100 minus 64. There is 36%. So 36 over 100. Okay, use your calculator. Then you will get 2970000. Change it to standard form 1, 2, 3, 4, 5, 6. So the answer will be 2.97 times 10 to the power of 6. A. Number 20. Diagram below shows the cubical steel block. The density of the steel is 7,750 km per meter per meter per meter. The steel block is mounted to form ball bearings with mass 200 grams each. Calculate the number of ball bearings formed. Okay, so you are given the formula for density. And we are also given the density of the steel is 7750. Okay, so for this cubical steel block, we can find the volume. Okay, which is 10 meter times 10 meter times 10 meter. 10 meter times 10 meter times 10 meter. Then you will get 1000 meter cube. Okay, so to find the mass of this steel block, we just use this formula. Density given. Volume we have calculated, so we have to find the mass. Density is 7750 equals to mass over volume 1000. Therefore, mass will equals to 7750000. Okay, this is in kg. Okay, the block is melted to form ball bearing with mass 250 grams each. Okay, 250 grams. This is in gram. So we change it. So we change this one into gram also. Therefore, you will have 7750000 gram. Then we divided by this one, 250 gram. Then the final answer will be 3100000. Change it to standard form. 1, 2, 3, 4, 5, 6, 7. So the answer is 3.1 times 10 to the power of 7.